What's the deal here?
Well, why are you
Half an hour is the earliest. Usually.
Blind is your soul. Blind is your soul.
Scrolling the scroll.
I'm not saying.
Because I can't scroll. I'm showing you the best people.
See, I want to. Really, I want to. No, but
I'll have to use the projector. I don't know why it's doing this again.
Who is you?
Oh, they made it. We feared the worst. We thought you died on the way here.
Is it always like that? I mean, like, the weather.
No, it's usually worse. There you are as well. Now we've got everybody. Okay. Let me just put this in. Come on, turn on. Okay. Right, you have to move. Probably don't want both projectors on at the same time. That will be a bit confusing. Move. Dude, move your laptop. HP, dude. There now. There now, that'll do. Okay. Next lesson, what are we on now? What's the next one? We did binomial last time. Actually, I've got it here. What's our next lesson now? Did I open this? No, I didn't. I think it's probably is it AP aromatic? Is it? Next one's so easy for babies.
not yet, baby.
Hey! Keep your language clean, please.
Love you.
Yeah, that's better.
Love you.
There's minors in this classroom, you know.
Happy The one you said. The one, two, the
What
one you
about
said,
you?
Q the minor.
That's disgraceful. Disgraceful. All right. So last time we were having a look at sequence. So now we're having a look at series. Does anybody know this word, series?
Yeah.
Right. Right. What's no. No. Anyone know series as in sequence and series?
Sequence cousins.
Nah, you can do better than that. Anyone? What's the difference between a sequence and a series? Does anybody know?
Series.
Not this?
Sequence. Series. One of them has a row.
No, no, okay, nobody knows. So this is a sequence like A1, A2, A3, A4, etc. And this is a series. A1 plus A2 plus A3 plus A4, etc. So the only difference is in a sequence the terms stay isolated, but in a series the terms are added together to form one number. Okay, so really the only difference is with a sequence you separate with a comma, and in a series the separation between the terms is a plus. And that's all. So really a series is the sum of a sequence. So a series is the sum of a sequence. Yeah.
I dropped something. Can I go?
What did you drop on your adventures here? Is it valuable? You should go get it.
Yeah.
Was it your phone?
No.
Okay, right, I'm good. Do you know where you dropped it?
No, I'll just.
Backtrack?
Yeah.
Okay. And that's the last we see of him. Right. Have we got this written down? Series is the sum of a sequence. You found it already? Was it right outside?
Yeah, over there.
Alright, okay. Well, that's a happy ending then to the story. Okay, let's have a look at some examples here. Can I scroll down? Yeah. So, firstly, to have a series, you must have a sequence first. So, let's just take something simple like the sequence UN equals, let's say, I don't know, 1 over n, for example. So, if I wrote this down, U1, that's 1, U2, it's a half, U3, it's a quarter, it's a third, and then U4 is a quarter. We did this last time, right?
Yeah.
This symbol here, it means sum. It's a Greek letter, sigma. And if I write this, it literally means to add from the first term to the fourth term, the sequence U. So it's U1 plus U2 plus U3 plus U4. So in this example, it'd be 1 plus a half plus a third plus a quarter. So this is the notation. So just to make note, this means sum. This is where you start. This is where you end. And this here is the sequence. Okay, please write this down and then we'll do some different examples. Let's see his calculator. Show me. He does have it.
Yeah. I just clicked it.
But then you say you don't have it.
Yeah. No, I wasn't talking about this. I was talking about something else.
Oh, right. Sure. Okay, do you have this one? Yes, we have this? No, we don't. Yes? Yeah? Okay. Alright, here's our first real example. So, for example, sum from 0 to 4 n squared. So first you use 0. That would be 0 squared plus 1 squared plus 2 squared plus 3 squared plus 4 squared. So that's 16 and 9 is 25, 30 in total, yeah? Here's another one. Sum 0 to, let's say,
So this UN is sequence or
the sequence. Now, you can put in UN or you can put the formula in directly. So in this case, I just wrote the formula in directly. Let's say we have something like 1 over n factorial.
To the 1.
5 seconds. That's all I needed, and you would have had the answer. We shall go to 5 again. Okay. I want you to try and do this, please. Give me the answer here. Yep. You should have gotten about 2.7.
Yep, 2.71. 163 over 60.
Okay, so this one here is 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2, 1 over 3, 1 over 4, and then 1 over 5. So what would that be? 1 plus 1 plus a half plus a sixth. What's that? Plus 1 over 32, is that right? Yes, that's right. Yeah, and then plus 1 over 180. People with calculators? No, you're forcing me to do it. It's not 32. Thank you.
163 over 60.
What's this one? After 4 factorial, 24. Of course, yeah. And this one is 120. So the total is roughly 2.718.
Yeah. Do we not give them the answer in fraction?
We can. It's just, it was easier for me to do this in my head as decimals than fractions. Okay. Try this one, it's a little bit different.
Are we allowed to use the calculator?
I'll show you how to do it in a moment. You can just use it to check your answer.
Oh.
6.
Oh, real quick, the n equal to 0 is where we begin?
Yeah. So this one will be 2 times 6 plus 2 times 7 plus 2 times 8 plus 2 times 9, which is 12 plus 14 plus 16 plus 18. 60. Yes? Now, I have a couple more interesting ones to do, but you can check this on your calculator. Watch carefully, please. Leave it, it's fine. Watch carefully. We have the sum button here, so we press shift and this sum button, and we get the sum. We start at 6 and we finish at 9, and we type the formula in using x instead of n, so this would be 2x. 2 alpha x, and we get this 60. So in the exam you know you have the right answer. Okay, let me give you one to try here. Yeah,
Can we just use the formula, like n times n plus 1?
yeah, now we haven't done any formulas yet, and I know some of these do have formulas you can use, but for today's lesson we're not looking at that. Right, try this one, please. 1 to 10. 1 over n squared. You know what? Actually, we'll do a smaller one first. 1 to 5, 1 over n squared, and then 1 to 10, 1 over n squared, and then 1 to 20, 1 over n squared. And you can use the calculator for practice here. Give me the answer as a decimal. So are we only missing now Lee and Nader?
That's it.
Is Omar here? Yeah, Omar's here. Yeah, good. Yeah. Okay, what's the first answer here?
1.46.
1.46. The next one?
1.55.
The next one? 1.5. 1.6, yeah? Now try this one if your calculator allows you to go to 100. Before you give me the answer, do you think it'll be a big or small number still? Small, yeah.
Not much different.
Not much different, yeah. What did we get?
1.63.
Yeah. Even though we're adding more terms, nothing much is changing. What is the adjective to describe this situation?
No.
Convergent. Convergent. So this series is convergent.
Yep.
Try this one. And then,
1.6.
what is it?
1 point.
Loading. Loading.
Yeah, the calculator approach. Exactly.
Come on guys, type this in and give me the answer here.
No. If this, then it should be an answer. How the range?
Still loading? Sorry, I couldn't resist an opportunity to troll your calculators. So in a few minutes it will come back to normal now, but it'll take a while to get through this calculation.
Can you try using yours?
Oh, let's see what happens. Yeah.
Oh, which one has it? Yeah, I think this would be faster than his laptop.
We'll see. We'll see.
1.64.
1.64, yeah.
Well, let's see how quick this one is.
Okay. Sorry.
Now watch this. It'll be so fast you won't even see it happen. Hang on. Ready now?
Yeah.
Hang on. It'll get there.
So what's the why does it do that?
It's going through the list from 1 to 1,000, adding all the terms up. So it has to go from 1 to 1,000. I thought it would be quicker on the computer.
Maybe not.
No, it's good. Yeah.
Sorry, but this was hurt.
What was it?
64.
1.4. Now try this one, please.
Yeah, how do you write? Oh. Yeah, how do you write it on the laptop? I don't think there is infinity, but...
There is not.
No, that's not random. That's random.
Right, so this program is more powerful than the calculator. So here is 1 to 1,000,
That's
100, sorry, 1 to 100.
100 to 1,000.
1,000, sorry. It's, oh hang on. Simplify, approximate 1,000. What, dude? Oh, that's because I typed it in wrong, sorry. Sum from 1 to 1,000, you get 1.6439. Now that was much quicker, wasn't it? Now let's put in a bigger number. Million? 1 to 1,000,000, we got not much difference, is there? Yeah, and let's do one more. How many zeros would you like? 17 zeros.
Yeah.
It's a very particular number, but 17 zeros, okay. 1 point, it's the same. So it's trying to reach some limit here. It's convergent. Right, so you can't go to infinity, why not? But then the program will continue forever. So we'll need to use something more powerful. Just a moment. Okay, yeah, I think I have it here. So, this will be pi squared over 6, believe it or not. Yes, I know, believe it or not. If you type pi squared over 6 on your calculator, see what you get. Yeah. See, I can't do these ones in my head because they're too easy, of course. It has to be this one at least. So my point is, sometimes these sequences converge, and sometimes what they converge to is not something you would ever guess. You know, if you were looking at this, you've no way of knowing that that's what it was trying to get to. Okay. Now, one more example, and then I'll give you some questions to do, because there's not a lot in this lesson. I want you to try and decide if this one is convergent, divergent, which of the two it is. So the way you could do it, you can try it on the calculator. You can go from 1 to 10, and then you could go from 1 to 100, and then 1 to 1,000. Or if you don't want to go to 1,000, maybe 200 if you're worried your calculator will freeze. So calculate these and then decide if you think this series will be convergent or divergent. Has this returned?
Divergent.
Write it down. The numbers, please.
For 10 it's 2.9. For 100, 3.1. Remember your what?
This language. 5.1.
No, I'm sure.
No, it's like waiting.
Okay, what do you reckon? Are we looking at something convergent or divergent?
Can you give us a minute?
Okay. Yes. You're doing 1,000, is it?
Yeah. The thing is diverse.
You think it's divergent?
Yeah.
The previous sequence 1 over n squared.
Yeah.
Which was that?
Oh,
Convergent.
then it's convergent. Sorry. Because it's a denominator that's increasing, so the number will keep reducing inside.
That is true.
But the answer is kind of
Well, let me...
1, 5, 7.
Let's look. Look. So, the first time I asked you to go to 10,
Yeah.
and you should got something like 2.9.
Yeah.
Yeah. Next time I asked you to go to 100. You got 5.18. Okay. Next time, what did I ask you to go to? 1,000.
7.4.
7.4. What about 10,000?
maybe 8.
9.78.
It will stop in the end.
No, that's right.
Well, let's keep going. Add in an extra 0.
Mine's still
12.
1,000.
Right.
Is it bigger or smaller?
It's getting slightly bigger each time, but not as much. So, what was this? 1, 2, 3, 4, 5. That was 10,000. A million. Processing. Calculating.
It's still not started calculating, because measuring the time it needs.
There we go.
Oh.
14.3. So that's not much of a difference between 12 and 14. It's going from 100,000 to 1 million terms. We've only added 2 to the total. So now, seeing all the evidence, what do you think? Convergent or divergent? And the answer is divergent. Yes. Believe it or not, although it's increasing very slowly, it does continue to increase to infinity. Just extremely slowly. This is the slowest divergent series you can have. It just about makes it to infinity, but as slowly as possible. When you look at other divergent sequences, they diverge much quicker than this. This one diverges extremely slowly, but it still diverges. There is no limit. It will continue to increase forever. No limit here. Will we put in one more? 10 million. So what, do you want to have a guess at what maybe it'll be? We've gone from 12 to 14, so
15.
maybe something like 15, and we go to 10 million. Now the last calculation took, what, about 10 seconds? 16 seconds. So if this is 10 times bigger, it has 10 times more terms to add. It should take about 160 seconds, right?
That's
No,
No, we need 40.
30 something.
30?
What?
16 multiplied by 10. 10.
No, it's 10 times.
It's 10 times more terms. We've gone from 1 million to 10 million. So it should take 10 times longer. Yeah? So it's 160 seconds, we think. So what if only 100 seconds to go?
Yeah, let's just wait.
Oh yeah.
Yeah, we don't have anything.
It's the end of the day.
Yeah.
Yeah, I think we should also try 100 million.
To confirm it's divergent.
Yeah.
Yeah. In the exam, you do get these in the exam, and they usually only ask you to do 5 terms, but they do want you to write down the 5 terms, like earlier here. They want to see this in the exam. If you only have this, you don't get the full marks because you maybe just did it on your calculator. You understand? So please, in the exam, make sure you write this work down for problems like this.
So we can just write that and calculate it. No problem.
You could, oh, you mean this and jump to this? Yeah.
So we calculate the number and we just
Yeah, yes, yeah. That's okay.
replace the terms with the n. Yeah.
Oh yeah, for the exam, as a minimum, I would need to see this, followed by this and this. I don't have to see this.
Yeah.
Shall we investigate?
Oh no.
What's it, 40 seconds?
Yeah.
I'm just thinking.
Yes.
It was 1/2n.
Would also be divergent.
Okay, then why is it 1 square? It becomes
That is an excellent question. What are you going to study next year?
mechanical.
You will discover next year in your math class.
Because both of them are increasing the denominator.
Mhm.
But it's just that this one is increasing faster than the other one.
The n squared increase is fast enough to cause it to converge, whereas n is not fast enough. Multiplying by 2 still won't make it fast enough. Multiplying by 1,000,000 still won't make it fast enough. It needs to be at least squared.
So if it's cubic,
Yeah, and 1 over n cubed would also converge.
Oh.
Oh, what happened?
158 seconds.
Yeah. 168 seconds, not bad. 16.69. So you see, it's still increasing. It's not appearing to be limited. So it actually diverges. But like I said, you add the first 10 million terms together and you get 16.7. That's not a big number for so many terms. Yeah. Okay, so for the homework, which you can start now.
Would it take the same time if it was n squared?
No, because you see, there is actually a way I think the computer can do it quicker with n squared, I think. Yeah, well, type of formula. 1 over n, I believe the computer has to individually calculate each term 10 million times. 1 over n squared, I think it can take a shortcut, I think. I don't know how the program works, I just have a feeling that this is what's happening. Right, what are we on? Series 36. Faisal, turn around and be quiet. Ian, Faisal, don't have a conversation across the room. I'm telling you which ones to do. Right.
Oh, I like that. Oh, why not?
You can do whichever ones you like, but I recommend that you can start them now. Do the right-hand column here, S to Z. Yeah.
Is there a way when you look at the problem, you can tell you can tell that?
No, you can't from just looking at it. There are some techniques and tricks you can do to check if it will be convergent or divergent.
How do you get that pi 2 over 6?
He read it somewhere.
In university, I remember the proof that this is pi squared over 6. And I know the proof. The proof is a little too advanced for this class, but I know that it converges to pi squared over 6. And the reason I remember it so clearly is because it was so unexpected. Why should pi enter this formula? This has nothing to do with it, but yeah, it does. You know.
You can blow our minds and show us.
You are not ready for it. No, you're not. No, not even close.
It even takes time for 2 plus n.
Yeah, it's not
But it doesn't take as much time.
Yeah, the reason for the time is not the difficulty of the calculation per se, but it's the amount of calculations. So it has to run through it 1,000 times, you know. Okay, try these now for a few minutes, please.